Dear students and my dear learners, this is my 18th video, and of course this would be the last video for first unit of engineering thermodynamics, in which I have efficiently I hope that I reached you and covered all the topics in the first unit. And also in the past three videos we have been solving the important problems from the basics and as well as the application point of view. Thanks for your kind support and cooperation and listening. I am very happy, and soon I will take the videos for second unit also. We will meet in that. Now in this video I am going to solve some more problem in SFEE and its application. Okay, shall we move to problem? Here and in the last video itself I shown this problem and told you people to try to explore and read the instruction or data is given in the problem. So let me now again read the problem. Here a turbojet engine is being given. So engine means you know very well, fuel and the air is added, and finally we are getting the exhaust gases, and our ambient air temperature is given, and gas temperature at the outlet of the nozzle is given. Enthalpy values for air and gas have been given, and fuel air ratio is there. Chemical energy of the fuel as a input was given, and incomplete combustion leads to 5% of the chemical energy of the fuel is not released. Okay, so heat loss, that is chemical energy lack of 5%, and heat loss from the engine is 21 kilojoules per kilogram of air. And now we have to calculate the velocity of the exhaust jet. Okay, here from this please look at this line diagram so that you can able to understand. Here first air and the fuel, they are given into the engine. Okay, so they have to get burnt, and then we will get after the combustion of these two ingredients we will get the exhaust gases at the cross section 3. So here we have two inlet and one outlet. Okay, and heat loss is given, and during the burning what happens, that data has been given, and some more details are there. Okay, so now here so as already we have solved one more problem in the heat exchanger, right? In the heat exchanger, input, all the inputs energies is equal to output energy is equal to output energy. So we are writing the same SFEE terms, that is energy terms, for air, fuel and heat supplied, because if the heat is available then only these both the inputs will get burnt or get combusted, and we are getting the gas terms. Okay, that is exhaust gas terms. Now here just substitute here enthalpy of the air has been given, and velocity is also given, and here you have mass of the fuel and its energy, plus here q has been given as heat loss, so it has taken in the negative sense, negative sign, and here mass of the gas, exhaust gases, and enthalpy as already has been given, and this velocity is not given in the problem. Okay, just to substitute other units, required units, and then Vg keep it as it is, plus other the energy from the gas. Okay, now here again if you simplify the equation by the mathematical juggleries, finally your answer would be in terms of Vg squared, and you can take square root to get the velocity of the exhaust gases. Okay. So simply from this line diagram you should understand that both the inputs, the summation of both the inputs of air and the fuel will give you, these are all both are reactants, this is the product, exhaust gas is the product. So you have to understand how to write this energy equation, either in the boiler or how to tell heater, water plus steam gives hot water, like that. If any of the problem has been given in such a way that some reactants and the product in between, they will be giving the data for heat transferred into or out of the system, and the work that has been extracted or absorbed by the system, that has to be taken with the right sign conversion, and then you have to substitute right now. Okay. So you can complete now. Next, this is also one of the very crucial problem, in which this power output of an adiabatic steam turbine. I told you what is the purpose of turbine. Turbine is to get the power output. The purpose of turbine is it has to deliver the mechanical work. Okay. So inlet and exit conditions of the steam as given, it is shown in this diagram here. P1, T1, V1 is that one, and same as at the outlet, and the work output of the turbine is also given. So compare the magnitudes of del H, del Ke and del Pe. So we have to complete the change in enthalpy, change in kinetic energy, change in potential energy, work done per unit mass of steam flowing the turbine has to be find out, and mass flow rate of the steam. Okay. So here this is a steady flow process only, because there is no any change in the mass and the energies in the inlet and outlet. So we are assuming, even if it is not given, you can take it as an assumption. Okay. So control volume, over the control volume, mass flow rate remains same, and energy conservation law also is being followed. The system is adiabatic, and thus there is no heat transfer. Okay. Because if you talk, please understand, my dear students, whenever we are talking about the steam turbine, you don't take into account or worry about the various heat transfers, other sort of the change in altitude, like that. Whatever the data, if it was not given, means you just leave it. Okay. Your purpose is turbine, means you should know or find out the work output, that needs change in enthalpy. Okay. Other all data, if they have given, means you can take into account of the change in enthalpy, change in kinetic energy, change in potential energy, anything can be included as a extra fittings. Okay. Like heater, means the purpose is to get the hot substances compared to input. Okay. If the compressor, means work input or work absorbing machine. Okay. Change in enthalpy only needs. Okay. Like that, you be clear with the application of that a device, that is most important. Okay. So here one twist has been done here. If you see, they have given pressure and temperature at the inlet. After completing all the units, you will be studying about this particular, in the third unit you will be studying how to find out the enthalpies if pressure and temperature has been given. So this is little bit advanced one. Okay. So you can find out the H2 and H1 depends upon the pressure and temperature values at the inlet and the outlet. So they have found out by using the steam tables, that soon I will tell you when you have to get that steam table and all. It is these portions are coming from third unit. They have just combined that fundamentals to here, and then you can find out H, and velocity has been given, so you can find out the change in kinetic energy, and change in potential energy also can be found out, since the difference in altitude is also given. And now again, next we are coming to our regular procedure. You state that energy is conserved over the control volume, and then write all the terms and then substitute it. Then you can get the work output from the turbine. And they are asking how much amount of mass flow rate of steam has to be supplied to get the power output of 5 megawatt. It has to give 5 megawatt. So to achieve that 5 megawatt of power, how much this is the work output per kg of steam was found out. Like, so how much amount of kgs has to be given to get the 5 megawatt power. Okay, that has been found out here, so that you can get the required mass flow rate of the turbine. Okay, so some more two more problems are also given by me. You sit and read and understand, and if you have any doubt you can post me later. And again, now let me review. 3 to 4 problems are there. Let me review in the first unit. This subject is concerned, as far as thermodynamics is concerned, it is most important course, because this would be fundamental to all the thermal related subjects which you are going to explore or study in your further higher semesters. So you try to how much effectively you prepare this subject would be very much helpful in your career, and as well as to complete the other subjects, thermal related subject also. And this is not so easy to imagine or understand the each and every concept simply by reading the book. So what you do is you just physically try to bring the things in front of your eyes, when you are giving the supplying the heat to any system. You know very well that the heat cannot be that is stored without leaving the system. It is not at all possible. Your mom is giving the hot water to you. If you don't drink for 10 minutes means it will become warm, and even again further 10 minutes if you don't drink means it would become a normal temperature, normal water. How is it possible? Since the heat cannot be held by any of the system. And if you see high grade energy work, that electrical energy, after it is undergoing all the processes, finally we are getting the electrical energy that we can store it in the UPS, right? Batteries and all, it is distributed to all the places. So work can be stored. So it is called high grade energy. And heat, why it is called a low grade energy is because of it always moves towards the higher temperature. Wherever the temperature difference exists, by various modes of heat transfers, that heat transfer modes also you will be studying soon in your heat transfer subject in the third unit at the third year, I hope. So what you do is please try to bring the concept physically in before your eye view, so that you can able to understand at least to some extent and follow the theories, and as well as to solve the problem. Okay. And one more thing is, here the basic terminologies and the units, especially the units, variable units, and the conversions from one measurement to another measurement, and substitute in the right unit is only easiest way to solve the problems. That you keep it in your mind. Without knowing the unit and without knowing the conversions from one form to another form, then it will be so tough to solve the problems. So be ready to learn the fundamental again, and please try to explore the fundamentals in detail, so that you can able to learn this subject well. All the very best. Meet you in the second unit videos. I am Dr. Suja, reaching you Thanks for patient listening. I am signing off now and meet you in the second unit. Bye.